Okay, ladies and gentlemen, these are the questions in your notebook. Okay, under O level 2007, section A, question 4. Alright, this question is about the Haber process, alright, used to produce ammonia. Okay, use the dot and cross diagram to show the bonding in ammonia. Okay, so show valence electron shell only. Okay, take note, ammonia is N, and the formula for ammonia is actually NH3. Okay, so there are 3 hydrogen. So nitrogen has 7 electrons, so hence my electronic arrangement will be 2.5. Alright, so if I were to draw 5 electrons, okay, I only need 3 hydrogen here, so I can only draw the structure in this way. Okay, so there are 3 hydrogen. Okay, and nitrogen here. Take note, I only use 3 hydrogen for bonding, so I'm left with 2 electrons on nitrogen which are not used for bonding. Okay, so that is the structure of ammonia. The catalyst used is finely divided iron. Okay, so explain why the catalyst has to be finely divided. Okay, because as the particle size increases, surface area to volume ratio alright, increases. So frequency of effective limiting particles increases. Right, speed of reaction. The speed of reaction here would infer to the speed of formation of ammonia. Right, so hence ammonia will form faster. Okay, so when the mixture of hydrogen, nitrogen, and ammonia enters the cooler, ammonia turns into liquid while other gases do not. Okay, so what does this tell you about the boiling point of ammonia? It is actually higher than nitrogen and hydrogen. Alright, if it's lower, it cannot be cooled down, because when they say it's cooler means normally it will actually mean that the temperature is actually lower than that of ammonia. Okay, because it's lower than ammonia, so hence the boiling it allows ammonia, which has a higher temperature, to condense. Okay, if you recall the what you call it, under the section of separation techniques. Okay, under separation technique, this method called distillation. For distillation, alright, there is one part which you use the condenser. Okay, so for the condenser, alright, you actually have a cooling jacket. Okay, so just a bit quick run through. So this is my setup here. Okay, so this is where you actually have the condenser here. Okay, so down here you have water in and water out. Okay, so over here you actually place your thermometer. The thermometer measures the boiling point of the liquid. Okay, so this is where you collect your distillate. So if I have a mixture of salt plus water, okay, so I have a mixture of salt plus water. Take note that the thermometer measures the boiling point of water. Okay, in this case, the boiling point of water is actually at 100 degrees Celsius. Okay, so this is your thermometer. So take note that the condenser actually has a lower temperature than the solvent that you are trying to condense. So in this case, alright, so in this case where I say it's water will be normally at about 25 to 30 degrees Celsius. So water has a higher temperature than the cooler here. So over here is all water. Okay, so because of that, then he is able to collect, all right, the to condense the liquid, the gas back to liquid. Okay, state one other reason other than cost why unreacted nitrogen and hydrogen is produced. That is actually to produce more ammonia. Okay, this is in your notes as I went through just now. Okay, student practice for 2009. A factory uses ammonia to make fertilizers. Essential conditions, alright, as I said, take note this is degrees, please put the degree sign here. Right, 450 degrees Celsius, pressure 250, finely divided iron. Okay, ammonia is used to make ammonium phosphate. Alright, contains NH4 plus and PO4 3 minus. So what is the formula? Okay, and PO4 3 minus. Okay, so which means that you need 3 of, if you cross, right, 3 here, and this is number 1, which is over here. Okay, so it's NH4 bracket 3 PO4. That is the formula for ammonium phosphate. Okay, ammonium nitrate has formula NH4NO3. Right, calculate the percentage by mass of nitrogen by using the formula below. Okay, how do you calculate the relative molecular mass? That we will calculate here first. We will calculate the MR of ammonium nitrate, NH4NO3. This will be equals to 14 plus 1 times 4, right, plus 14 plus 16 times 3. Okay, this will give the answer of 80. Okay, so when they say AR of the element, alright, it's actually the atomic mass of one, and they say it's AR means atomic mass. Atomic mass refers to the element. Atomic mass of element in this case is actually nitrogen. Nitrogen actually have a mass of 14, right? Use the bigger number, which is the atomic mass. So percentage, it will be, I have 2 nitrogen atom, 1 N here and 2 N here. So it's 14 times 2. This is where they say AR of the element times the number of atoms. I have 2 nitrogen atoms, right? Divided by the MR, which is 80, then times 100%. Okay, so 28 divided by 80. So it is actually 35%. Okay, so that is how you calculate the percentage of an element in a compound. You will also learn this in the next section of chemical calculations. Alright. Okay, part C. Phosphate PO4 3 minus are present in wastewater. One way of treating is to remove phosphate ions by adding calcium ions. The calcium ions react with phosphate ions to form precipitate. You are asked to write the ionic equation, alright, with state symbols. Okay, so because they say calcium ions, okay, react with phosphate ions. So calcium ion Ca2 plus, alright, because calcium is actually from group 2. Right, so group 2 elements actually form a charge of 2 plus when it loses electron. Okay, and it is in aqueous state because they say it's wastewater. Okay, so water, so which means the calcium has to dissolve first. And phosphate is PO4 3 minus, also dissolved in water. When they say it is a precipitate, so the state symbol that is assigned will be solid. Right, Ca3 PO4 bracket 2. So you need to balance the ionic equation as well. Take note, over here I have got 3 calcium atoms, so I need 3 calcium ions. And here means that the whole phosphate ion, there are 2 phosphate ions present. So it means I have to have 2 PO4 3 minus. Okay. Next, for part D, the wastewater contains nitrate ions. Why can't nitrate ions be removed by precipitation? Okay, because if you refer to the section on solubility of salt, nitrate ions are soluble in water. So any salt that's soluble, you cannot remove. Okay, part E, bags of ammonium nitrate fertilizer have the following printed warning. Do not add fertilizer to soil that has been recently treated with any lime containing product. When they say lime containing, it can be either your calcium oxide, right, or calcium hydroxide. So the purpose of these two chemicals is actually to reduce soil acidity. Okay, so why do you add calcium hydroxide to soil? Is to reduce the soil acidity. Why can't you add, right, ammonium compounds to soil that has been treated with calcium hydroxide? Okay, so you actually produce ammonia gas. Okay, I actually make reference to this here. Okay, so this is calcium hydroxide, okay, reacting with ammonium nitrate. So the reason is here. So ammonia gas, which has a relative molecular mass of 17, is light. So it will escape into the atmosphere and will not be retained in the soil to be absorbed by the plants. The nitrogen, can you please add? Nitrogen, alright, will not be retained by in the soil and to be absorbed by the plants. Okay, we need the nitrogen element for the plants. Okay, so over here, so it will escape to the atmosphere and nitrogen will not be retained in the soil to be absorbed by the plants. Right, so these are the two questions which are in your notebook. Next, can you please try the questions in the worksheet? Alright, the answers are similar, alright, and then they only change the context. So this means that hopefully by the end of the worksheet, you will be able to answer questions related to ammonia. Right, so please try the worksheet question. Thank you.